At ERO 347 hours on March 14, 1945, Lieutenant Junior Grade Robert Bobby Kearns, 23 years old, crouched behind the wheel of PT 371 as the patrol boat throttled down to 12 knots in the Sulu Sea, 40 nautical miles southwest of Basulan Island, in the Philippines. The moon was a thin crescent. Visibility maybe 200 yards in the pre-dawn darkness. Kearns had 3 50 caliber machine guns, one 37 millimeter cannon, and a crew of 12 men who had been hunting Japanese supply barges for 8 consecutive nights without a single confirmed kill. The problem wasn't finding targets. Intelligence reported 15 to 20 barge runs per week through this sector. The problem was killing them before they scattered into the mangrove networks that lined every inlet along these islands. Kearns needed overwhelming firepower in the first 30 seconds of contact, not a sustained gun battle that gave the enemy time to beach their cargo and disappear. But the PT boat, designers had built his vessel for torpedo attacks against destroyers, not close-quarters barge hunting in shallow water. He had speed and maneuverability, but not enough concentrated punch to shred a convoy of heavily laden barges in a single pass. That was about to change, because bolted to the foredeck of PT 371, where the forward torpedo tube had been 6 days earlier, sat 8 5-inch high-velocity aircraft rockets in a makeshift wooden rack that motor machinists Mate First Class Eugene Gene Walcott had cobbled together using lumber from ammunition crates and angle iron salvaged from a wrecked Japanese Zero. The United States Navy entered the Pacific Theater with a patrol torpedo boat designed around a specific mission profile that was already becoming obsolete by 1943. The Elko 80-foot PT boats displaced 43 tons at standard load, could reach 41 knots in calm seas with 3 Packard engines, generating 4,500 total horsepower, and carried 4 Mark 13 torpedoes as their primary armament. The doctrine was straightforward: attack enemy capital ships at night, launch torpedoes from point-blank range, escape using superior speed. By mid-1944, that doctrine had collapsed under the weight of operational reality in the Southwest Pacific. Japanese destroyers rarely ventured into the shallow coastal waters where PT boats operated. Instead, the primary targets had become supply barges, coastal freighters, and the wooden-hulled vessels that moved troops and materials through the island chains. These targets were too small and too shallow draft for torpedo attacks. They required gunfire, and PT boats were chronically undergunned for this mission. The standard PT boat armament evolved throughout the war, but by early 1945, most boats in the Southwest Pacific carried one Bofors 37 millimeter automatic cannon forward, twin 50 caliber machine guns in a turret amidships, 1 or 2 additional 50 caliber guns mounted aft, and maybe a 20 millimeter or a Lacan, if they were lucky. This generated impressive noise and muzzle flash, but insufficient destructive effect against hardened targets. Japanese supply barges were built from 1/4-inch steel plate over a hardwood frame, measured 40 to 60 feet in length, and could absorb hundreds of 50 caliber rounds without sinking. The 37 millimeter could punch through the plating, but its rate of fire was limited to 120 rounds per minute, and ammunition capacity on the cramped PT deck was restricted to maybe 300 rounds. A typical engagement lasted 90 to 120 seconds before the barges either reached shore or scattered beyond effective range. The mathematics were brutal. If a PT boat encountered a convoy of 6 barges, it could deliver perhaps 250 rounds of 37 millimeter and 3,000 rounds of 50 caliber in that time window. That might cripple 2 barges and damage a third, but the rest would escape. Squadron commanders in motor torpedo boat, Squadron 3, operating from Mindanao, recorded that 73% of barge encounters between November 1944 and February 1945 ended with enemy vessels reaching shore before being destroyed. The real problem was concentrated firepower in the opening moments of contact. PT boats achieved surprise maybe 40% of the time when conditions were favorable. Dark nights, heavy weather, complex coastlines. That surprise lasted 15 to 20 seconds maximum. In those seconds, the boat needed to deliver catastrophic damage to multiple targets simultaneously. Machine guns couldn't do it. The 37 millimeter was too slow. Torpedoes were useless. What they needed was the explosive payload of a destroyer's 5-inch gun battery, compressed into a weapon light enough for a 43-ton boat to carry, and powerful enough to obliterate a supply barge with a single hit. That weapon existed. It was sitting in ammunition dumps at every forward air base in the Pacific. It was called the High Velocity Aircraft Rocket, and nobody had seriously considered mounting it on a boat until Bobby Kearns spent an afternoon at Malabang Airfield watching P-38 Lightnings load out for ground attack missions. Kearns was not supposed to be at Malabang on March 8, 1945. PT-371 had limped into Parong Bay with a fractured fuel line on the center Packard engine, and the tender USS Oyster Bay didn't have the replacement parts. The squadron maintenance officer, Lieutenant Commander Harold Stokes, 41, a former civilian Marine engineer from Seattle, told Kearns that a Navy construction battalion unit at Malabang might have suitable copper tubing. Kearns drove a jeep up the coastal road, found the CBs, secured the tubing, and was heading back to his jeep when he heard the distinctive shriek of rockets being fired. He walked to the flight line and watched ground crews loading HVARs onto the wing rails of P-38s, preparing for an afternoon strike against Japanese positions on Jolo Island. The HVAR designated the 5-inch forward-firing aircraft Rocket Mark IV, weighed 134 pounds, fully assembled. The rocket motor itself was a solid fuel unit, generating 6,000 pounds of thrust for a burn time of 0.6 seconds, accelerating the weapon to approximately 1,300 feet per second at burnout. The warhead was a naval 5-inch 54 caliber shell containing 8 pounds of Composition B explosive filler, the same projectile fired by destroyers' main batteries. Effective range was approximately 2,000 yards when launched from an aircraft traveling at 250 knots, but accuracy was poor, beyond 1,000 yards. The Army Air Forces and Navy carrier groups used HVARs primarily against ground targets, hardened structures, and light vessels. A single HVAR could penetrate 4 inches of armor plate or punch completely through a wooden vessel's hull and detonate inside the target. The explosion would typically blow out a section of hull plating measuring 6 to 8 feet in diameter. If you want to see how Bobby Kearns convinced his squadron commander to let him bolt aircraft rockets onto a patrol boat and take them into combat, please hit that like button and subscribe to the channel. This is the story of how desperate innovation in the island warfare of 1945 created a weapon system the Japanese would come to fear as much as any in the American arsenal. Kearns spent 20 minutes at the Malabang flight line, examining the HVAR mounting rails on a P-38, asking questions of a bemused Army Air Force's ordnance sergeant named Daniel "Danny" Foster, 26, from Corpus Christi, Texas. Foster explained the firing mechanism, a simple electrical circuit that sent current through an igniter plug in the rocket motor. The system was deliberately crude to function reliably in combat conditions. The pilot flipped a master arm switch, selected the appropriate weapon station, and pressed the firing button. Current flowed, the igniter sparked, the rocket motor ignited, and punched the weapon off its rail. The rails themselves were hollow aluminum tubes, with 3 lugs that engaged corresponding grooves in the rocket motor casing. Total weight per rail was 18 pounds. Foster mentioned that Marine Corsairs operating from escort carriers sometimes used HVARs against Japanese coastal targets in the Philippines, and that those attacks were devastatingly effective. Kearns drove back to Parang Bay with an idea forming. At 17:30 hours that evening, Kearns presented his concept to Lieutenant Commander Stokes and Squadron Commander Thomas "Tom" Denton, 34, a former merchant marine captain from Mobile, Alabama. The proposal was simple. Remove the forward torpedo tube from PT-371. Fabricate a wooden mounting platform on the foredeck. Install aircraft rocket rails and wire them into a firing circuit controlled from the cockpit. Load 8 HVARs. Take the boat on a standard patrol, and if they found barges, fire all 8 rockets in a single salvo from approximately 500 yards. Denton's first response was that it sounded insane. His second response, after Kearns explained the ballistics and destructive capability, was that it sounded worth trying. The squadron had lost 2 boats in the previous 6 weeks, both 2 shore-based artillery that had opened fire, while the PT boats were still trying to sink barges with machine gun fire. Anything that could reduce engagement time from 2 minutes to 20 seconds would save lives. Denton authorized a 72-hour trial fabrication period. Gene Walcott, the motor machinist, who would build the actual launcher, was 31 years old from Meridian, Idaho, and had operated a machine shop before enlisting in 1942. He had access to the Oyster Bay's workshop facilities, but the available tools were limited to a hand-powered drill press, hacksaw, arc welder, and basic metalworking equipment. Aircraft rocket rails required precision mounting angles. The HVAR had to launch with its longitudinal axis aligned within 2 degrees of the desired trajectory, or the weapon would tumble and miss by 50 yards or more. Walcott had no engineering drawings, no blueprints, and no precedent to follow. What he had was 4 HVAR mounting rails that Kearns had acquired from the Malabang Ordnance Depot, a supply of lumber from ammunition crates, salvaged angle iron, and his own experience building engine mounts for crop dusting aircraft in Idaho during the 1930s. The work began at 0800 hours on March 9th. Walcott started by removing the forward Mark 13 torpedo tube from PT-371, a job that required unbolting the tube's base mounts and carefully disconnecting the firing mechanism. The tube weighed 630 pounds. Its removal shifted the boat's center of gravity aft by approximately 8 inches, which would slightly improve handling in rough seas. The foredeck now had a clear space measuring roughly 9 feet long by 6 feet wide, with the existing deck structure capable of supporting maybe 800 pounds of additional equipment before reinforcement became necessary. 8 HVARs, fully loaded, weighed 1,072 pounds. The launcher assembly would add another 200 pounds. Walcott needed to distribute that load across the deck's structural frames. He built the foundation first, using 2-inch thick mahogany planks cut from ammunition crate lids to create a platform that spread the load across 4 deck frames. The platform measured 8 feet by 5 feet and was bolted directly through the deck into the underlying structural members with 3/4-inch steel bolts. On this platform, he constructed 2 parallel mounting beams using 4x4 lumber reinforced with salvaged angle iron along their lengths. These beams ran fore and aft and were spaced 36 inches apart. Each beam would hold 4 rocket rails, 2 upper, 2 lower, in a stacked configuration. The rails themselves had to be angled upward at approximately 5 degrees above horizontal to account for the rocket's ballistic drop over typical engagement distances. Walcott achieved this by cutting wooden wedges that tilted the rails to the precise angle, verified using a machinist's level and basic trigonometry calculations. By 1630 hours on March 9th, the basic platform was complete. Walcott spent the evening of March 9th and the morning of March 10th fabricating the electrical firing system. The HVAR firing mechanism required approximately 12 volts at 3 amperes per rocket. Firing 8 rockets simultaneously would demand 24 amperes, well within the capacity of PT-371's 24-volt electrical system. Walcott ran heavy-gauge copper wire from the boat's main electrical panel forward to the launcher position, installing a master arm switch and firing button near the helmsman's station. The circuit included safety interlocks that prevented accidental firing, unless the master arm was engaged and the firing button was depressed simultaneously. Each rocket rail received its own electrical lead, terminating in a contact plug that would mate with the igniter plug on the HVAR motor when the weapon was loaded. The first test fit of an actual HVAR occurred at 14:20 hours on March 10th. Kearns and Walcott loaded a single rocket onto the upper left rail position, engaging the motor casing lugs with the rail guides and connecting the electrical igniter plug. The rocket sat at a slight upward angle, its nose extending approximately 3 feet beyond the bow of the boat. They verified that the electrical circuit showed continuity, then carefully removed the rocket. The system appeared functional, but nobody knew what would happen when a rocket generating 6,000 pounds of thrust ignited 3 feet from a wooden boat's superstructure. Cat. Source 9:45 hours on March 11th, PT-371 motored out of Parang Bay into open water with 8 HVARs loaded on the foredeck launcher. Kearns had selected a test site approximately 12 miles offshore where water depth exceeded 300 feet, deep enough that a malfunctioning rocket wouldn't hit bottom and potentially create a navigation hazard. The target was a derelict Filipino fishing boat hull that another PT had towed to the test site and anchored. The hull was roughly 40 feet long, similar in size to a Japanese supply barge. Kearns positioned PT-371 at 500 yards range, bow on to the target. The wind was 8 knots from the northeast. Sea state calm, with 1-foot swells. Conditions were ideal. Kearns engaged the master arm switch and pressed the firing button at 1,003 hours. All 8 rockets ignited simultaneously. The noise was extraordinary, not the sustained roar of machine gun fire, but a sharp, tearing shriek that lasted less than a second as 8 rocket motors burned out nearly instantaneously. The blast pressure from the motor's exhaust swept across PT-371's foredeck, scattering loose gear and momentarily stunning the crew with overpressure. The boat lurched backward slightly, losing perhaps 2 knots of speed from the rocket's combined thrust vector. Thick white smoke from the rocket motors obscured the bow for several seconds. Then the warheads detonated against and around the target hull. 6 rockets struck the fishing boat directly. 2 missed by approximately 15 and 20 yards, overshooting and detonating on impact with the water beyond. The 6 hits were catastrophic. The fishing boat hull literally disintegrated, transforming from a solid object into a rapidly expanding cloud of wood splinters, metal fragments, and spray in less than 1 second. When the smoke cleared, there was no recognizable wreckage floating at the target position. Only debris fragments measuring less than 3 feet in any dimension, scattered across a 100-yard radius. The elapsed time from firing to complete target destruction was 4.3 seconds. Kearns throttled up to 30 knots and motored through the debris field. The largest intact piece he found was a section of keel, perhaps 5 feet long. Everything else had been shredded beyond recognition. The crew of PT-371 returned to Parang Bay at 12:47 hours on March 11th. By 1500 hours, every PT boat commander in Squadron 3 knew about the test. By 1800 hours, Commander Denton had drafted a preliminary report for motor torpedo boat squadrons, Southwest Pacific, recommending immediate evaluation of HVAR installations across the squadron. The response from higher command was cautious. Rear Admiral Morton L. Deo, commanding Destroyer Squadron 21 and overseeing PT boat operations in the sector, authorized a combat evaluation period of 2 weeks. If PT-371 could demonstrate effective use of the rocket system against actual Japanese targets, the modification would be considered for wider implementation. Kearns was authorized to conduct offensive patrols beginning March 13th. PT-371 launched on its first combat patrol with HVARs at 22:45 hours on March 13th, 1945, heading northwest into the Sulu Sea toward known Japanese barge routes between Basilan and Jolo Islands. The crew consisted of Kearns, Executive Officer Ensign Michael Mike Thornton, 22, from Portland, Oregon, Motor Machinist Walcott, Gunner's Mate, 2nd Class, Raymond Ray Parker, 24, from Gary, Indiana, manning the 37mm cannon, Radio Man, 3rd Class, James Jimmy Sullivan, 19, from Boston, and 7 additional crew members assigned to machine guns, engine room duties, and deck operations. The boat carried 8 HVARs on the foredeck launcher, full ammunition loads for all guns, and fuel for 8 hours of patrol operations at cruising speed. The patrol sector covered approximately 200 square nautical miles of open water and coastal approaches. Intelligence reports indicated Japanese barge traffic typically moved at night, hugging coastlines, traveling at 6 to 8 knots. The barges were usually organized in convoys of 4 to 8 vessels with minimal defensive armament, maybe 1 or 2 light machine guns per barge. They relied on darkness, shallow draft, and the ability to beach rapidly in emergencies. PT-371's mission was to intercept these convoys while they were still in open water, destroy as many barges as possible in the initial attack, then engage survivors with conventional gunfire. Contact occurred at 0347 hours on March 14th, exactly as described at the beginning of this account. Radar operator Sullivan detected multiple small contacts at 7,000 yards, bearing 315 degrees. Kearns altered course to intercept, reducing speed to 12 knots to minimize wake visibility. At 4,000 yards, The crew could visually confirm 6 vessels in a loose column formation moving southward, parallel to the Basilan coast, approximately 1 mile offshore. Kearns increased speed to 28 knots and closed to 1,000 yards before the Japanese barges reacted. At 800 yards, he throttled back to 18 knots and steadied on a course that would bring PT-371 bow on to the convoy's flank. At 540 yards, he armed the rocket firing circuit. The first salvo fired at 0352 hours. 8 rockets streaked across the darkness, their motor exhausts creating brilliant white trails that persisted for perhaps 2 seconds before fading. Flight time to target was less than 3 seconds. 7 rockets impacted the convoy. The lead barge took 2 direct hits amidships and simply ceased to exist as a coherent vessel. The explosions were bright orange flashes that lit up the entire convoy and the surrounding water for a fraction of a second. The second barge in line took 1 hit near the stern, which detonated its cargo, probably ammunition or fuel, creating a secondary explosion that threw burning debris 50 feet into the air. The third barge was struck by a rocket that passed completely through the hull without detonating and exploded in the water on the far side. But the damage was sufficient to stop the vessel dead in the water. 2 rockets hit the fourth barge simultaneously, breaking the vessel's back and causing it to fold in the middle. The remaining 2 barges in the convoy immediately turned toward shore and opened their throttles. Kearns brought PT-371 around in a tight turn, increasing speed to 35 knots to pursue the fleeing barges. Without the rocket launcher, this would have been a prolonged gun battle. With the HVARs expended, Kearns relied on the boat's conventional armament. Gunner's mate Parker opened fire with the 37mm at 300 yards, walking rounds up the stern of the nearest barge. The 50 caliber guns joined in, raking the vessel's superstructure. At 200 yards, one of the barge's fuel tanks ruptured, and the vessel slowed dramatically. Parker continued firing, putting 14 rounds into the barge's waterline before it began settling. The 6th and final barge reached the beach before PT-371 could close to effective range, and its crew abandoned ship, disappearing into the jungle. The engagement lasted 11 minutes from first contact to final shots fired. 5 barges destroyed or disabled, 1 escaped. Total ammunition expenditure: 8 HVARs, 147 rounds of 37mm, approximately 2,800 rounds of 50 caliber. PT-371 suffered no damage and no casualties. Kearns estimated that without the rocket salvo, the engagement would have lasted at least 30 minutes and resulted in perhaps 2 barges destroyed, with the remainder escaping to shore. The force multiplication factor was immediately obvious. PT-371 conducted 4 additional patrols between March 15th and March 21st, 1945. The second patrol, on March 16th, resulted in contact with a 3-barge convoy at Orfaura 19 hours near Malanipa Island. All 3 barges were destroyed by the initial rocket salvo, with no requirement for follow-up gunfire. The 3rd patrol, March 18, found no targets. The 4th patrol, March 20th, engaged a single large cargo barge at Ora 103 hours. Kearns fired only 4 rockets, conserving the remaining 4 in case additional targets appeared. All 4 rockets hit, sinking the barge in less than 20 seconds. The 5th patrol, March 21st, intercepted a 7-barge convoy and destroyed 6 in the opening salvo, then sank the 7th with gunfire as it attempted to beach. By March 27, 1945, PT-371 had expended 40 HVARs in combat and destroyed 18 confirmed Japanese vessels with an additional 3 probables. The rocket system had suffered 0 malfunctions. Admiral Deo authorized expansion of the HVAR modification program to all boats in Squadron 3 effective March 25. Motor Machinist Walcott became the de facto instructor, training other boat crews on launcher fabrication and installation procedures. By April 15, 1945, 23 PT boats in the Southwest Pacific were operating with HVAR launchers. By May 1st, that number had increased to 47. The modification program encountered significant logistical challenges. HVAR supplies were allocated primarily to aviation units, and requisitioning rockets for PT boat use required navigating Navy and Army Air Forces supply chains that weren't designed to support such requests. Squadron commanders began stockpiling HVARs whenever possible, sometimes acquiring them through unofficial channels. Lieutenant Commander Stokes established relationships with Army Air Forces ordnance officers at forward air bases, trading Navy spare parts and supplies in exchange for rocket inventory. By late April, Squadron 3 had accumulated approximately 600 HVARs in various storage facilities throughout the Philippines. Installation procedures evolved as more boats received launchers. The basic design remained Walcott's wooden platform with aluminum rails, but improvements included reinforced deck structures, better electrical systems with redundant safety features, and adjustable mounting angles that allowed crews to optimize trajectory for specific engagement ranges. Some boats installed 12 rocket launchers. Others experimented with 16 rocket configurations. The larger installations required removing both forward torpedo tubes and added significant top weight, which affected boat handling in rough seas. Most commanders settled on 8 rocket systems as the optimal balance between firepower and vessel stability. Japanese response to the rocket-equipped PT boats was documented in captured intelligence reports and prisoner interrogations beginning in late April 1945. Japanese barge crews operating in the Philippines began referring to the rocket-armed boats as Kaminari Akuma, literally thunder demons, or lightning devils, because of the distinctive sound and visual signature of the HVAR salvos. Multiple captured documents indicated that Japanese supply operations shifted their timing and routes specifically to avoid areas where rocket-equipped PT boats were known to patrol. Barge traffic in certain sectors decreased by an estimated 40 to 60% between April and June 1945, as Japanese commanders diverted supplies through more circuitous routes or relied on larger vessels that could defend themselves more effectively. The official United States Navy analysis of the HVAR PT boat program was completed by the Bureau of Ordnance in July 1945. The report documented that rocket-equipped PT boats achieved an average target destruction rate of 78% in engagements where rockets were fired, compared to a 32% destruction rate for conventionally armed PT boats in similar engagements. Average engagement time decreased from 147 seconds to 31 seconds. Ammunition expenditure per target destroyed decreased by 63% when rockets were available. The report recommended formal adoption of HVAR systems for all PT boats operating in coastal interdiction roles, with standardized mounting kits to be manufactured and distributed to forward squadrons. Production of standardized HVAR launcher kits began in August 1945 at naval facilities in San Diego, California. The design incorporated lessons learned from field modifications in the Philippines. The kits included prefabricated aluminum mounting platforms designed to bolt directly to PT boat deck structures, 8 rocket rails with precision-machined mounting hardware, a complete electrical firing system with fail-safe interlocks, and detailed installation instructions. Each kit weighed 184 pounds and could be installed by a 3-man crew in approximately 16 hours. The Navy ordered 500 kits for distribution throughout the Pacific Theater. Japan's surrender on August 15, 1945, occurred before most of these kits reached operational units. Bobby Kearns survived the war. He separated from the Navy in December 1945 with the rank of lieutenant and returned to his family's construction business in Spokane, Washington. He never spoke extensively about his wartime service and declined multiple requests for interviews about the HVAR program. He died in 1989 at the age of 67. Gene Walcott remained in the Navy, serving until 1962 and retiring as a chief warrant officer. He returned to Idaho, operated a marine engine repair shop in Coeur d'Alene, and occasionally gave talks to local veterans organizations about his experiences with PT boats. He died in 2001 at the age of 87. Commander Tom Denton transferred to staff duties in 1946 and retired from the Navy in 1958. He worked as a maritime consultant until his death in 1976. PT-371 survived the war and returned to the United States in late 1945. The boat was decommissioned in February 1946 and eventually sold for scrap. No complete PT boat equipped with an original field-modified HVAR launcher is known to survive. Several museums possess PT boats from the World War II era, but none retain the rocket launcher modifications created during the Philippine campaign. The standardized launcher kits manufactured in 1945 were largely destroyed or scrapped in the immediate post-war period as the Navy rapidly demobilized. The broader legacy of the HVAR PT boat program influenced post-war naval doctrine regarding fast attack craft and asymmetric warfare. The concept of mounting heavy aircraft ordnance on small vessels demonstrated that technological innovation could occur at the tactical level when operational necessity demanded it. Modern patrol boats and fast attack craft in numerous navies employ similar philosophies. Lightweight platforms carrying weapons originally designed for aircraft or larger vessels. The principle remains unchanged: maximize destructive capability while maintaining speed and maneuverability. The statistical record stands as testament to field innovation's impact. Between March 14 and August 15, 1945, rocket-equipped PT boats in the Southwest Pacific destroyed an estimated 347 Japanese vessels with approximately 2,800 HVAR firings. Conventional PT boat operations during the same period destroyed approximately 218 vessels, while expending vastly greater quantities of gun ammunition. The average PT boat crew member serving on a rocket-equipped boat faced a 23% lower casualty rate than crew members on conventionally armed boats, primarily because shorter engagement times reduced exposure to enemy fire. The Japanese lost an estimated 4,000 tons of supplies and equipment to rocket attacks, representing approximately 12% of their total coastal supply capacity in the Philippines during the final 5 months of the war. If this story of battlefield innovation and the men who transformed aircraft weapons into naval firepower helped you understand another piece of World War II history, Please hit that like button and subscribe to see more stories like this. Leave a comment below telling us where you're watching from and whether anyone in your family served in the Pacific Theater. Their stories and their innovation helped win a war and deserve to be remembered. Thank you for helping keep that memory alive.